Good morning, everybody. I am Dr.Dhondiba Ishwanath, Assistant Professor of Chemistry, Government First Grade College, Puram, Bangalore. Today I am going to discuss about organic halogen compounds of second sem B.Sc Chemistry, which is affiliated to Bengaluru North University. This organic halogen compound consists of 4 modules. We have to explain one by one, and today's class I have to explain module 1, in which organic halogen compounds, definition with examples, then classification of organic halogen compounds, then alkyl halides, definition, nomenclature with examples, then classification of alkyl halides with examples. Now I can explain one by one. Now definition of organic halogen compounds. Those organic compounds which contains one or more halogen groups are directly attached to the alkyl or aryl group called organic halogen compounds. The minimum condition is 1, that is a halogen group will be present around directly attached to the alkyl or aryl group called, that is a organic halogen compound, and examples are here 3 different examples I have mentioned. One is methyl chloride, second one is bromobenzene. It is a halogen group. The bromo is a halogen group directly attached to the aryl group, that is a benzene ring. Therefore it is a aryl halide, and this is the chloro group is the halogen group directly attached to the alkyl group. Therefore it is called as a alkyl halide. And another condition is nothing but in definition itself, it contains more than one halogen groups are also possible. Therefore 2 chloro groups present in this compound. Therefore we say that is a 1,2-dichloroethane is the another example. I quote another example, 1,2-dichlorobenzene also we can give, that is a compound. Those compound which contains 2 halogen groups are directly attached to the aryl group. Therefore they are called as organic halogen compounds. Now coming to the classification of organic halogen compounds or organic halides. Now first one is alkyl halides, second one is aryl halides, and third one is aryl alkyl halides. According to your syllabus, they are classified into 3 categories. One is alkyl halides, second one is aryl halides, third one is aryl alkyl halides. We have to study one by one. Now first, alkyl halides. Now those organic compounds in which a halogen group is directly attached to the aliphatic carbon atom or alkyl group, and it does not contain any benzene ring, called alkyl halides. The general formula for monoalkyl halides can be written as Rx, where R is equal to alkyl group, X is the halogen group. This is the general formula for monoalkyl halide, because monoalkyl halide means it contains only one halogen group directly attached to the alkyl group. Therefore it is called as a monohalogen compound. And the general formula here, and R is nothing but here directly alkyl group, and there is a, it doesn't contain any benzene ring, and hence it is called as a alkyl halides. Now suppose example we have to put R is equal to CS3 in the general formula, Rx, and X is equal to Cl, then this is the methyl chloride. Suppose R is equal to propyl, we have to put, therefore propyl bromide, and X will be Br, and therefore we will get, that is a propyl bromide. These are the example for alkyl halides. Now coming to the nomenclature of alkyl halides. The naming of the alkyl halides can be done by using 2 methods. One is common name system, another one is B.Sc name system. Common name of the alkyl halides can be obtained by uttering name of the corresponding alkyl group followed by name of the halide. It is a 2-word system. Therefore that is alkyl halide. And second system is nothing but B.Sc name system, in which the name of the B.Sc name of alkyl halides can be obtained by using following rules. First rule say that select the longest possible carbon chain containing a functional group halogen. you have to select longest possible carbon chain such that it contains a halogen group. Second one is number the carbon chain such that halogen group should be come on least number of carbon atom. This is the second rule. And third rule, name of the alkyl halides is obtained by prefixing the halo. Halo is nothing but fluoro for that is fluoro, chloro, bromo, iodo to the parent word of the corresponding alkane. That is halo plus alkane. It is a haloalkane. Haloalkane is the IUPAC name of that parent compound. And fourth rule is nothing but the other substituents are present in the compound. They are numbered, named as prefixes according to their alphabetic order. And these are the four rules for giving the name of organic halogen compounds. Now I have to give that is the example sum. I have to explain some example. First one is formula, second one is common name, third one is IUPAC name. Suppose this is the methyl, this is the CS3Cl, this is called as a methyl chloride. This is the methyl group and followed by that is the halogen halide, name of the halide. Therefore name the alkyl first, then halogen name. Therefore methyl chloride is the these are the two word system. This is the two word system name, and here it is IUPAC name is the only one word system. You have to prefixing halogen group before the name of the alkane. Therefore chloromethane. This is one carbon atom, therefore methane, and chloro will be there, chlorine will be there, therefore it is called as a chloro. Chloromethane is the IUPAC name of this compound. Second one is ethyl bromide. Ethyl bromide is the common name, and this is the bromoethane is the IUPAC name. Then similar to propyl chloride, then it is the chloropropane is the IUPAC name. Then suppose the methyl chloro group is present at the second carbon atom, then we say that is the isopropyl chloride. Here three carbon atoms are there, and chloro group present at the secondary carbon atom. It is present at the secondary carbon atom, therefore we called as a it is isopropyl chloride. Or it is a numbering. Suppose you have to say that is a select the longest possible chain. Here also you have selecting, here carbon atom only one is there, therefore one chloromethane also, or simply chloromethane is the name of this compound. Here we are numbering takes place 1 2, therefore that is a 1 bromoethane, or it is also simply it is called as a bromoethane, or 1 bromoethane you can also write. This is the 1 2 3, therefore chloropropane you have to write. Now here numbering should be takes place such that 1 2 3 from left to right or right to left. The number should be, the chloro group should be comes on the least number of the carbon atom. Therefore from either side of the numbering it is takes place at 2 carbon atom, hence both side naming is correct one. Therefore 2 chloropropane is the name of this compound. Again the tertiary, that is the tertiary butyl chloride. This is the secondary butyl chloride. This is the secondary carbon atom. This is 4 carbon atom, and therefore it is called as a secondary butyl chloride is the common name of this compound. But IUPAC name you have to numbering should be from left to right. This is the 1, this is the 2 3 4. 4 carbon atom means butane, and this is the halogen group will be there, that is chloro. Therefore chlorobutane is the, that is a at 2 position chloro group will be there, therefore 2 chloro butane is the IUPAC name of this compound. Similarly you have to write that is a here isobutyl chloride. Here this is the isobutyl chloride we can say, but numbering should be takes place from here. You have to select the longest possible carbon chain. This is the, here chloro group is there, 1 2 3 or 1 2 3 whatever may be, the numbering should be same, and therefore we say that is a 1 chloro. This is the one, that is a methyl group is the another group will be there, therefore 2 1, this is the 2 methyl, that is the propane. Therefore it is the longest possible carbon chain is nothing but 3 carbon atom chain, and methyl group is the substituent, and this is the chloro group is a again functional group. Therefore 1 chloro 2 methyl propane is the IUPAC name of this compound. And another example I quote here, tertiary butyl chloride. Tertiary butyl chloride, here tertiary carbon atom, in which that is this carbon atom surrounds 3 methyl group and 1 halogen group, therefore called as a tertiary butyl chloride. And IUPAC name should be right as a, you have to select the longest possible carbon chain such that it became 1. Here's numbering 1 2 3 or 1 2 3. There 1 2 3, either you have to write that is any direction, it the chloro group will become side, that is the second position, and another methyl group will be present at the second position, and longest possible carbon chain is nothing but a propane. Therefore we say that is a 2 chloro, therefore 2 chloro 2 methyl propane is the IUPAC name of tertiary butyl chloride or this compound. And these are the about some example about IUPAC name of compound. Now coming to that is a classification of alkyl halides. The alkyl halides are classified into different category based on the, that is the first one is, there are 3 category are there. First one is primary alkyl halide. Those alkyl halides in which halogen group is directly attached to the primary carbon atom called that is a primary alkyl halide. Or we say those alkyl halides in which a halogen group, alkyl group and 2 hydrogen groups are directly attached to the same carbon atom called that is a primary alkyl halides. The general formula for primary alkyl halide can be written as R, that is CH2X. Here in this note, this is called as a primary carbon atom. This carbon atom surrounds 2 hydrogen atom, 1 halogen group and 1 alkyl group. Therefore it is called as a primary alkyl halides. Again it is possible also, suppose R is putting that is a hydrogen, this is also belong to that is a primary alkyl halide. R may be here H or any alkyl group. You have to put any alkyl group. H means methyl chloride is a primary alkyl halide exceptionally. R and methyl, that is ethyl bromide, whatever maybe you have to take, that is example, they are all are, that is a primary alkyl halide. Example I have put here, suppose R is equal to H putting, we will get that is a methyl chloride. X will be chloride, therefore we will get that is a methyl chloride. Suppose R is equal to CH3, then it is a ethyl bromide. After putting that is X is equal to Br. Suppose I is equal to X is equal to iodide and R is equal to that is CH3 CH2, then it is called as a propyl iodide. These are the example for that is a primary alkyl halides. Now coming to that is a second classification, that is secondary alkyl halide. It is written as abbreviatedly 2 degree. It is 2 degree, but it is read as a secondary alkyl halide. Those alkyl halides in which 1 halogen group is directly attached to the secondary carbon atom called secondary alkyl halide, or those alkyl halides in which a halogen group, 2 alkyl groups and 1 halogen group are directly attached to the same carbon atom called secondary alkyl halide. The general formula for secondary alkyl halide can be written as R2CHX. Here R2 groups are there and that is CH will be there. Here C, so this carbon atom surrounds 1 hydrogen, 1 halogen and 2 alkyl groups are present, hence it is called as a secondary alkyl halide. Now example is nothing but, suppose R is equal to taken methyl, therefore this is the secondary propyl chloride. Suppose CH3 ethyl, we have to write this is the formula for alkyl halide. Again you have to giving that is another example, we can write these are the compounds for that is our example for secondary alkyl halides. Now coming to that is a third classification of alkyl halides, that is called as a tertiary alkyl halide. It is abbreviated as 3 degree. Those alkyl halides in which halogen group is directly attached to the tertiary carbon atom called that is a tertiary alkyl halide, or those alkyl halides in which a halogen group and 3 alkyl groups are directly attached to the same carbon atom are called tertiary alkyl halide. The general formula for tertiary alkyl halide can be written as R3CX. There is no hydrogen atom. Therefore, this carbon atom is a tertiary carbon atom because here this carbon atom surrounds 3 alkyl groups are there and 1 halogen group, and there is no hydrogen atom will be there. Therefore, it is called as a tertiary alkyl halide. And example is nothing but you have to say there is a tertiary butyl chloride, tertiary butyl chloride, then tertiary ethyl bromide, then tertiary propyl iodide. We can write the example for tertiary alkyl halides. This completes about that is module 1.